University. Renee walked us through the fundamentals of Xamarin.Forms, and now for the next hour, we're going to continue that conversation by diving into navigation and XAML. Now, as a reminder, Xamarin University is your one-stop shop for everything Xamarin. Xamarin University has many cool features. For example, we offer a large selection of live instructor-led classes, which you can attend as many times as you wish. We offer one-on-one office hour sessions with an instructor to discuss your mobile development questions. And we also offer the ability to become a Xamarin certified mobile developer. In this session, we have three main topics that we want to discuss. First, we're going to continue the trivia application by adding navigation support. Our current project already has a navigation page in place, but now we're actually going to perform navigation to multiple pages. Having the new pages created, we're going to then design them using XAML, which is a markup language designed by Microsoft. And then finally, we're going to turn on XAML compilation, which is an optimization that we can make to help improve the loading times of our pages. As I mentioned before, our current application has a single home page. However, that's not really practical. If you look at any app store, the majority of applications that you'll find have multiple pages. It would probably be very difficult to find an application with just a single page. So a very common navigation pattern is called stack navigation. This enables you typical forward and backwards navigation. And as you can see here in this example, we have an iOS application, and as I make selections, I navigate through the application. You can even see the navigation bar at the top changing in respect to the current page. The term stack navigation gives a lot away about how it's actually implemented. It's being implemented by an internal stack, so we use terms like push and pop for insert and remove. In stack navigation, when you push a page onto the stack, the topmost page is always the visible page. So if I pop a page off, the previous page will now be the visible page. We implement stack navigation in Xamarin.Forms by using the navigation page class. This is what we did in Renee's session, but now we're going to go ahead and we're going to look at how we can actually do the navigation. So it turns out that every single page in Xamarin.Forms has a built-in navigation property. And using the navigation property, we can access the navigation page if we are indeed inside of a navigation page. So the navigation property has a push async method on it that we can use that accepts the page that we want to navigate to, and also a bool flag to indicate if we want that navigation to be animated. The navigation property also exposes methods to go back in the navigation stack, or pop pages off. So we have pop async that allows you to take the current top page of the stack, pop it off of the stack, and now the previous page will be visible. And we also have pop to root async, which allows us to pop all the pages off until we hit the first initial page of the stack. Now, another cool thing about navigation page is that it automatically manages the navigation bar on all platforms for you. The navigation bar can display a back button, a title, and also an optional icon for some platforms. Even though navigation page is managing the navigation bar for us, Xamarin.Forms still exposes properties and methods to customize the appearance of the navigation bar. So we have properties like title and icon, which allow you to change both the text of the navigation bar and the icon respectively. We also have a set of methods like, for example, set back button title to allow you to change the text of the back button. We also have set has back button to enable or disable the back button. And we finally have set has navigation bar to either enable or disable the navigation bar itself. So now let's go ahead and jump into our first demo. We're going to continue from where Renee left off. Remember, Renee created a navigation page, but now we're going to actually use the navigation APIs to push the questions page onto the navigation stack. All right, so here we are. Here is the solution that Renee left us off with. And if we start in app.cs, remember, we have this main page. This is essentially the initial page to display, and we're pointing it at a navigation page. Now, the navigation page's root page is the home page. And inside of home page, Renee built a basic UI that has an image and a button to navigate to the questions page. So you can see here, we have the click event set up and we have our event handler down here. So this is where we're going to put the code to actually navigate to the next page. Now, in order to, we need to have the actual questions page created. So we're going to create it as a XAML page, although we really didn't go through that yet. We will in a little bit, but we're going to add the XAML page to our portable class library. So I'm going to right click on the portable class library. I'm then going to go to add new item, and I'm going to click cross platform. Now there's 4 basic files that we can use. We have a forms page, a forms view, a XAML page, and a XAML view. So the forms page is just a simple content page, but it's all done through C# code. The forms view is also in C# code, but this is a reusable view. It's sort of like a smaller page. The XAML page is the same exact thing as a forms page, except we can design the UI using XAML code. And the XAML view is the same thing as a view, except we can build the reusable view using XAML. So let's go ahead and create a forms XAML page. We're going to call it the question page. And then click add. Alright, so here is the XAML page. Now we're going to come back in a little bit to discuss the actual details of this. So for now you can leave it alone. But if you look in the Solution Explorer, you can actually see we have a XAML page and a XAML.cs page. So if I open up the XAML.cs page, this is actually the code behind file for our XAML page. And you can actually see one important method call in here, which is initialize component. Initialize component is really just saying, hey, go ahead and parse that XAML file. Take every single element or control defined in the XAML file and load it into memory. The reason why this is important is because if you try to access any of the controls defined in your page before initialize component runs, you'll actually get an exception because they haven't been created yet. So you want to make sure that you don't talk to the UI until initialize component has finished running. Alright, now let's actually handle the navigation. So I want to make it so that when we navigate to the questions page, we definitely know we're on the question page. So back in the XAML, really quickly, let's just change the text of the label that was created automatically to say question page. Now that we have that, let's go to the home page, and inside our buttons click event, let's actually go ahead and do the navigation. So remember I told you that every page has a navigation property. And if you actually are inside of a navigation page, you can use this property. So I'm going to say navigation.put, and I'm going to pass in the page that I actually want to navigate to. So I'll say new questions page. There's also another version that takes in a bool, whether or not you want this to be animated. So if I say true here, it will be an animated navigation. Now this is an asynchronous method that returns a task. So I'm going to go ahead and say await right here. Now we can go ahead and actually run the application. So I'm going to run it on Android, but in platform, and it should work just fine. You can see that Android is bold right now. That's because I made that my startup project. You can do that by just right-clicking and selecting Set as Startup Project. Now if I hit the play button, it's going to go off and actually deploy my Android application. It's going to show the home screen, but remember, we're inside a navigation page. So if I click Start Exam, you can see we navigate to the questions page. We also have a navigation bar, and if I hit the back button, we go back to the home page. All right, now let's go ahead and jump back and let's talk about the specifics of XAML. So up until now, we've really been creating our UI in C# code. And you can continue to do that, but there are some disadvantages to it. So first, when we mix our UI and our logic together in the same file, it ultimately just makes the file a lot larger. The larger the file is, the harder it is to actually maintain and figure out what's going on. Like for example, here you can see we have a method to create a button, and then right below it, we have the actual click event for the button. So we're mixing this logic together, and ultimately, this is going to make it harder for someone to maintain just because there's more code involved. And finally, another reason why it's better to not have your UI described in code is that it really prohibits the role of a designer. Now I know currently Xamarin.Forms doesn't have an actual designer, but when that day comes, we'll be able to separate the UI creation and the actual logic that's driving the application between an actual graphic designer and a programmer. Today we're going to be talking about XAML. XAML is a markup language that was created by Microsoft to describe user interfaces in WPF. And during this, we learned that markup languages are really great for describing user interfaces because of three basic things. First, markup languages are considered to be toolable. And that means that we can build software that emits markup language for us so that we don't have to get into the low-level details. So for example, I could have a designer where I drag and drop a button onto the screen, and behind the scenes, it's really just generating markup language that represents that button on the screen. Markup languages are also human readable. That means that if you want to get into the details, you can just very easily read the markup, make small changes here and there. You really don't have to understand it too much to be able to make fine-tuned changes. And finally, markup languages are extensible, meaning it's very easy to add new features to the language. For example, supporting new tags. XAML stands for Extensible Application Markup Language, and like I said, it was designed specifically to describe user interfaces. So XAML was originally designed to work with WPF, and this was released in 2006 as part of .NET 3.0. It was then used for Silverlight, and now it's currently being used by WinRT applications. And then finally, it's also being used for UWP applications. And lucky for us, we can now use it with our Xamarin.Forms applications. So as you can see, XAML is used in a lot of different technologies. And because of that, it's very mature and very extensible. It's also very easy to understand because it doesn't introduce its own set of tags. Rather, it uses the underlying object model. So the same exact classes that you're using to build your UI programmatically will come over to XAML. You use the same exact tags. There's no difference. So if you've used XAML with other technologies, then you have an advantage because Xamarin.Forms XAML is based off of the XAML 2009 spec, but ultimately it's just XAML. So in this diagram, you can see on the left-hand side, we have a WinRT application, and on the right-hand side, we have a Xamarin.Forms application. And they're both really describing the same UI, except notice that the tags are different. Because remember, XAML is based off of the underlying object model. So in Xamarin.Forms, the controls are things like content pages, stack layouts, entries. But in WinRT, there are things like page, stack panel, and text box. Now you may be confused with some of these tags and attributes, so let's go ahead and take a look at some basic XAML code. So the first thing I want to start off by saying is XAML is case sensitive. So make sure you are using the correct casing on everything you type. Now XAML really consists of things that are called elements. Elements relate to objects behind the scenes. And we have attributes which relate to properties or events. Now remember, XAML is just text. It's basically a string. And when the application's running, this string is going to get parsed. And essentially, the parser is going to look at all the elements. So for example, let's say it sees label. It's going to say, oh, I have a label in XAML. Let's go ahead and create a new label behind the scenes, an actual label object. So it would say something like label L equals new label. Now when it sees attributes, for example, text on that label, it's just going to take that text and it's going to plug it into the object that was created for that label. And finally, XAML is all about relationships. When we create element tags, there's ways that we can have an opening tag and a closing tag. So for example, with stack layout, you can see here's our opening tag and here's our closing tag. Everything in between those are considered to be children. So the label, the entry, and the two buttons are children of the stack layout. So one interesting thing you may be noticing right now is that all the values of our attributes are strings, even though they may not actually be strings. So if you dive deeper into this, we have an example of a label here. We have things like text, font size, text color, etc. And notice how every single value is a string. Well, it turns out that behind the scenes, for example, text color is not actually a string. It's actually a color object. So how are we getting from string to object? And it turns out that behind the scenes, we're using this thing called a type converter. A type converter is responsible for taking a string and figuring out how to create an object from that string. The system does provide many of the common type converters for you, but if you needed, you could create your own type converter for your own custom object as well. Another interesting thing that you'll see is attached properties, and these are really used commonly for layout reasons. For example, here we have a grid, and inside the grid we have a label and entry that we're trying to position using column and maybe row properties. Now, it doesn't make sense to define column and row properties on the label and the entry classes directly, because what if the label and entries weren't being used inside of a grid? Maybe they were being used inside of a stack layout instead. So in that case, it really wouldn't make sense to have a column and a row. So attached properties essentially come from their parent. You can see the syntax of an attached property is the owning type dot the property. So grid is our owner type, and then the property is called column. So this is really coming from the grid class. It's also very common to see the use of content properties. These are essentially default properties. So this is best understood by just looking at code. In the top snippet of code, you can see we have a content page and a label inside of it. And if we were to build this and actually run the application, we would have a new page with a label that says this is the text inside of the label. We know, however, behind the scenes that a content page has a content property and a label has a text property, but we aren't setting them. The reason we don't have to set them is because of the use of a content property. Essentially, there's an attribute called the content attribute that we can apply to a class to indicate what a default property should be for that class. So for a content page, the default property is the content property, and for a label, the default property is the text property. So essentially, these two snippets of code are equivalent. On the bottom half, I'm indicating very specifically what properties I want to use, whereas on the top, I'm just using the default properties instead. Now that we have the basic idea of XAML, we want to be able to access the controls that we create in the XAML in our code behind file. Right? If I create an entry or a button in XAML, in my code behind I want to be able to access those. For example, what if I want to pull out the text that was typed into the entry? I need a way to talk to it. And the way that we do that is we use an attribute called xName. So you can see here on the entry control, we're giving it an xName called phone number. Now, when you give a control a name, it creates a field that represents that name. So we called our entry phone number, and it created a field of type entry called phone number. However, notice where this field is defined. It's being defined in a .xaml.g.cs file. It turns out that the system automatically generates this file as well. This is the file that essentially represents the XAML in code. Notice how this is where the actual definition for initialized component lives. You can see when you call initialized component, it calls a method called load from XAML, which essentially goes off and then parses the XAML file. Notice that this class called main page is being marked as a partial class. Our code behind file that we use is also a partial class. If you don't know what partial means, it essentially is a way of splitting up a class definition between multiple source files. So this source file and our code behind source file are the same exact class. So because I define this field in this class, it will be available in my code behind file as well. So going into our code behind, you can see we can access this field, we're saying phone number, and then we can subscribe to events or access properties. Here, we're subscribing to the text changed event. So as we type and the text changes, it's going to fire off the event handler on text changed. Now, because we're talking about XAML, I also want to bring up the fact that we can also subscribe to events in XAML. All we have to do is we can set an attribute for the event name, and then we just plug in the name of the event handler. So because there's two ways to subscribe to an event, you're probably wondering, well, which one should I use? Although it may be convenient to wire up the events in XAML, many developers prefer to actually subscribe to events in code because it keeps the UI and the behavior separated. This also makes it harder to break something. For example, if I accidentally remove the event inside of XAML, I wouldn't really know that there was a problem until I ran the application. Whereas if I did something similar in code, I would definitely get a compile time error. So now we're going to go ahead and do our next demo where we're going to finish building our UI using XAML. So here we are back in our application, and we're now going to start building the XAML for our question page. Let's start by removing the label. And what we're going to be working on is this. This is what the question page is going to look like. And you can see we have a label, two buttons, and then another button at the bottom. So if we take a look at this and kind of break it down, you can see that we have a row, and another row. So essentially, this is row 0, row 1, row 2, and row 3. There's 4 rows in total. And we also have 2 columns. If you draw a line there, you can see that we have the left column and the right column. So let me shift these around so that we can see both of them as we work. All right, so let's start by building our grid. And it's kind of hard to see, but the grid has some padding and some spacing inside of it. So let's go ahead and create the grid. We're going to add some attributes, padding, which we'll set to 20. And we'll also add some column spacing. That will be 10. And we'll have some row spacing as well, which will be 20. Then we'll go ahead and close the grid. So anything inside of the grid will be a child of the grid. Now inside the grid, we're also going to define rows and columns. So we have those 4 rows that I described before. So let's create them. To do that, we'll say grid.rowDefinitions. And inside our row definitions, we'll add a definition for each row. So we'll start off with row definition, and we'll set the height to be auto. And we'll just copy this, so you don't have to type. All of them are going to be auto besides the third one, which is going to be star. So just explaining this quickly, auto just means take the size of the content inside of it. And then star means, essentially, since there's only one star, take all the available space for yourself. That's the reason why the rows for the label and the buttons are pretty tight to the size of the control, but then the row in between here is a very large gap because it's taking all the available space, and then the last row is the same height as the button as well. Next, we're going to define the columns. So the same idea, we'll say grid.columnDefinitions, and inside we'll create column definitions. Now for our column definitions, we're going to set the the widths, and we'll set the widths to star for each. Now, when we have 2 widths that are star, essentially they're going to share the available space. They're basically proportional. So if I had one that was 2 star and the other was 1 star, the 2 star would be twice the size as the 1 star. But all stars essentially get the available space that's left over. So because they're both 1 star, they'll take the available space and divide it equally. That's the reason why when we have this column going down the center, each side is perfectly equal. So next, let's start creating the actual controls. So while we stay inside the grid, we're going to create the first label. So we'll say label. We'll give the label a name so that we can access the label from our code behind file. So we'll call this label question. We'll also give the label a column span. So column span, I'll explain in 1 second. And then we'll also give it some text. Right now we'll just plug in saying question. So basically, column span says that this determines how many columns this will take. So because we have 2 columns, we want the label to go from the first column to the second column. The reason why we're not specifying where this label should be placed is because by default it's going to be placed in the first column and the first row. But because it has 2 span, it will be in the first row and the first 2 columns. Next are the buttons. So let's create the first button, which is the true button. So we'll say button, we'll give it a name. We'll call it button true. We'll also give it a row. We'll say grid.row equals 1. That's an attached property. We'll give it some text saying true. We'll give it a text color saying white. And then we'll also give it a background color. And this is just going to be some predefined value that I'm going to paste in for that bluish color. And then let's also create the second button. So this is another button. We're going to give this a name as well. We'll call this button false. We'll give it the position of row 1, column 1. The text will be false. And the text color will also be white. And the background color will also be another built-in value or a predefined value. So this is for red. So just explaining the grid row and column positions, the reason why the true button has a row of 1 and we're not saying column is because row 1 is, well, first the second row, so that's correct. And the default column is the first column. So that's why we're not saying it. You could put it in if you want, but we're just ignoring it. And the second button, we're saying second row, which is correct, and second column, which is also correct. All right, so before we continue on, let's pause for a second and run the application just to see if it's coming out how we want. So as you can see, it's coming out pretty well. This is where we're going to put the question, and the true and false buttons look correct as well. Now, one thing we don't see in this picture is the response. When a user makes a selection, we want to inform them whether they were correct or incorrect. So we create a label that goes about there to display that result. So let's create that label. So we'll say label, we'll give it a name, we'll call it label response. We'll give it a position, so we'll say grid.row equals 2, and then we'll also give it some temporary text called response. So if I run it now, we'll see that it's going to be displayed right below the buttons. And the reason why it's there is because this is row 0, row 1, row 2. Finally, we have our next button. So this is going to be a button. Name is going to be button next. Position will be row 3, column 1. The text will say next. The text color will be white. And the background color will be another value that I'm just going to copy and paste in. So just to run the application one more time, you can see that it's coming along pretty well. Everything seems to be looking good. Now the basic UI is done, we're going to start working on the actual logic to drive this. So first we're going to add some code. We're going to create a class called game that essentially just has basic logic to manage the game flow. So I'll create a class called game, and I'm just going to take the code from another file and paste it in. And we're not going to spend time going through this. It just contains some basic logic to process and handle our game. Now, as you can see, we're also missing the quiz question. So let's create another class called quiz question. And I'm going to do the same thing. I'm going to copy some code. And this is just a very simple model modeling a question. It has a string for the question, a bool for the answer, and a string for the explanation. So let's save these and close them. Next, we're going to actually create a property or a static property of type game inside of our application class. So in here, we're going to say public static game, and we're going to have a property called current game. This is so that we can access this from anywhere in our program, since there's only going to ever be one game going on at a time. Alright, now let's build the logic for our question page. So let's get rid of this picture and go full screen. So we're going to start off with just creating a field to hold our reference to our game. So we'll say game, and then inside the constructor, we'll just pull that from the app. Now we're also going to make a method called initialize controls. This is just going to, subscribe to events. We'll get back to this in a second, but we'll call this from our constructor. We're also going to create a method to reset our UI. So we called void reset UI. Inside of that, we're going to reset the text of our labels. So we'll say label question.text equals game.currentQuestion.question. So whatever question we're currently on, pull the text from that. And also let's set the response just to an empty string. And then finally, we'll also just reset the enabled property on some of these controls. So we'll say button true dot is enabled equals true, button false dot is enabled equals false, and button next is enabled equals false. This should be true. Next, we're going to create another method called void on answer. This will allow us to basically submit what we chose, whether we hit true or false. So we'll say if the answer was true, then let's tell the game that they said true. Else if the answer was false, let's tell the game that we said false. Once we do that, let's update the response label with whether or not we were correct. So we'll say label response.text, and this will be equal to game.currentResponse is equal to game.currentQuestion.answer. So we're saying if our response is equal to the answer, then let's display correct. Otherwise, let's display incorrect. And then let's change the is enabled properties once again. So for button true, it'll be false. For button false, it will also be false. And then for button next, that will be true, so that we can navigate to the next page, but we can't submit a second answer. Now, going back up to the initialize controls method, let's go ahead and say that when I tap on button true or button false, we subscribe and we invoke the onAnswer method. So we'll say something like button true dot clicked. We'll use a lambda expression, and we'll say onAnswer, and we'll pass in true to say that they submitted true, and we'll do the same thing for false, but we'll just submit false instead. So now we're hooked up to onAnswer. Next, I want to handle, well, what happens when I click the next button. So let's first, we can just create an event for that, or subscribe to the event. We'll say button next dot clicked plus equal, and I'll hit tab 2 times, hit enter. That will then generate the event handler for me. And inside of this, I'll say if game.nextQuestion is true, then let's reset our UI. Else, we'll show a new page. We're going to show the page saying that we're done, meaning we have no more questions. So we'll push this new review page, which we haven't created yet. We'll come back to that. The last thing I have to do is inside the initialize controls method, let's just reset the UI. So just going through this entire file really quickly, we start off, we initialize component or controls. This will then go ahead and subscribe to all of our click events and reset the UI. If I click on true or false, it calls onAnswer, submitting our answer to the actual game. Once we check to see if we were correct or not, we'll display correct or incorrect into the response label and update the button's isEnabled properties to allow us to navigate to the next page. If you hit the next page button, it will essentially change the question, and it will actually return a value to indicate whether or not we can go to the next question if we have one available. So if it's true, that means it went to the next question, so we say reset UI. And when we call reset UI, it's going to pull out the new question and display it. If there is no other question available, then we're going to push to the end, and we'll just push a review page to display how many answers you got correct versus incorrect. Now let's create the review page. This is just going to be a simple page with a single label. So we'll create a XAML page again, call it review page. Now all we're going to do is just delete the text, and let's just set a name instead. We'll set the name to label result. Inside the code behind for this, after our initialize component, we'll just set the text. So we'll say label result.text is equal to, we'll use the C# 6 string interpolation feature. We'll say great, you got, and we'll plug in app.currentGame.get number of correct responses out of, and then we'll plug in app.currentGame.number of questions correct. So this should display the number of questions that we got correct out of the total questions. We could now go back to the questions page and uncomment this line because we created the review page. Now we need to actually have the questions. So using the provided questions.json file, we're going to add that now. So let's create a folder. So we'll say add new folder. We'll call it data. And now I'm just going to drag and drop in the questions.json. There it is. So if you open this up, you'll see that this is just a basic JSON file with some questions. And then finally, we're going to head over to the app.cs, and in the onStart method, we're going to just copy a snippet of code to let's add some of these in. So this piece of code is just going off, reading that file, the JSON file, and then deserializing it into a list of quiz questions. We then instantiate the game instance, passing in the questions. This also doesn't have to be async, so we can remove that. And let's also make sure that we set our questions.json file to be an embedded resource as the build action. And now the last thing to do is just run it. And let's see if it works. So I'm going to click Start Exam. We have a question, so you can see it is pulling from the JSON file, and it is getting deserialized. So it says, Xamarin.Forms is a great choice when developing mobile business applications or prototypes. So that's true. You can see it displays correct. Hit Next. Xamarin.Forms is a great choice when you are required to follow pixel-perfect mockups or leverage a lot of platform-specific features. I'll say false, which is also correct. Hit Next. Let's just guess on these other ones. And then at the end, it brings us to the review page, which it says we got 3 out of 5 questions correct. So everything's looking pretty good. All right, so let's jump back and talk about a couple more things. In our trivia application, we're interacting with the UI directly in our code behind file. For example, when we want to update a label's text, we just change the text property on the label control. And this is perfectly fine for smaller types of applications. But as your application grows, it may have some disadvantages. First, this could lead to a maintenance issue. There could be times where we have to make updates in multiple places in our code behind. And this even happened in our trivia application. There are a few spots where we change the text of labels, and we also change the isEnabled property of the buttons. Another problem that we have is testability. We have a bunch of logic inside our code behind file that we would probably like to unit test. Except the problem is that there's really no way of doing that unless we run the application itself. So what we'd really want to do is somehow take the logic inside the code behind file and make it so that it does not depend on the UI. Essentially make it more loosely coupled so that we can test that logic independently of the user interface. And finally, because our UI is tightly coupled to our code behind logic, changing one does affect the other. So we really want to create a more loosely coupled system. Now, a possible solution to these problems is what we call data binding. Now, we don't really have enough time to go through this in detail, but essentially data binding is a way that we can implement this intermediary object to loosely couple the UI and our model data or logic. In data binding, the binding itself is the middleman. We have a source and a target. The source can be any object, and we can bind to any public property on that source. The target is what we call a bindable object, and it has to have a bindable property on it. So for example, a label is a bindable object, and the text property is a bindable property on it. Now, by setting up the binding correctly, we could bind to that label's text property, and if there were changes to the actual underlying data, the binding will automatically update the text of the label without having to write any additional C# code. And finally, this conversation tends to always lead to MVVM. MVVM is an architectural design pattern, and it stands for Model View View Model. Now, once again, we don't have time to go through MVVM, but just note that data binding has an important job in MVVM. It essentially is what makes it possible to decouple the view and the view models. So if this all sounds interesting to you, I highly recommend you check out Xamarin University. At Xamarin University, we have classes covering both data binding and MVVM, and a whole large set of other topics as well. Now, I want to talk about one last topic, and this is going to bring us back to the initialize component method. Remember, I told you that you don't want to talk to your UI until the initialize component method finishes running. And the reason is because when this gets called, this essentially tells the system to parse your XAML file, which is just text, and load it into memory. So every time it sees an element tag, actually create an object in memory. Now, this probably sounds like a great system, and it is. It works fine. However, there are some problems because of it. The most obvious problem caused by parsing is loading times. You could imagine if every time I load a page, I had to first parse the XAML, it would increase the time it took in order to display that page. And you could imagine, on top of that, the larger that my XAML file is, the longer it will take to load the page. So the solution to these problems is compiling the XAML code instead of parsing it. So the idea is to take the XAML files at compile time, generate C# code statements that represent the XAML, and then include that in the assembly instead. And this provides a few benefits. Like I said, this will help reduce the load time of pages. This will also reduce the size of the overall assembly because text files are a little bit bigger than just having some C# code. And this will even help us provide some more validation with our XAML because it's going to be validated now at compile time. So currently, XAML compilation is disabled by default, but here's one way to turn it on very quickly. All we have to do is set this assembly level attribute, and we'll pass in the parameter of compile. And by just doing this, it will now start generating C# statements instead of parsing your XAML. So I'm going to quickly switch back to the trivia application and just enable XAML compilation. So here we are, back in app.cs, and I'm just going to add this assembly level attribute. Let me copy this code snippet, and I'll paste it right there. Now, by just running the application, we're not going to see anything different, but note, behind the scenes, it actually is a little bit more performant. So let's just run the application one last time to validate that everything is still working. And as you can see, everything is still working just fine. So in this session, we looked at a bunch of things. We talked about navigation and how we can push a page onto the navigation stack. We then looked at XAML and how we can describe our pages using this markup language. We also looked at how we can give our XAML elements names so that we can access them in our code behind file, and also how we can then wire up events either through code or through XAML. So I don't want you to stop here. Once again, I want to point out Xamarin University, because Xamarin University offers a set of free self-guided courses to get you started. So I highly recommend you head over to university.xamarin.com/self-guided to check them out. So in the upcoming session, Jason is going to take our application to the next level. You're going to begin moving pieces of the trivia application up into the cloud by integrating Azure Web Services into our application. I appreciate you all taking the time to listen, and I hope you all learned something new. I'm looking forward to seeing more people at Xamarin University, so go ahead and check it out. Thanks again, and enjoy the rest of the sessions.